I'm giving away this laptop the moment this video gets 1 million views, because I truly believe that this tech is going to be revolutionary. But just in case you don't win, I'm going to spend the next 20 minutes explaining exactly how I configured this computer. But first I have to show you what makes this so unique. At first glance, it doesn't seem so special. It's running Fedora Linux, where I can open Steam and play any of the Linux supporting games in my library using my NVIDIA GTX 3050 Ti GPU. You can see here I'm playing Valheim with stable performance. But the special thing about this computer is how it solves one important problem facing the Linux gaming community. The biggest problem facing any Linux enthusiast and PC gamer is there's always one game or one program that just won't work on Linux. Usually the only solution is to reboot to Windows, and usually you end up spending all your time in Windows because switching back and forth is such a pain. But this laptop solves that by letting me run one command to disconnect my GPU and pass it to a GPU-accelerated Windows virtual machine where I can play my Windows-exclusive video games with the full performance of my modern hardware. You can see how easy it is here for me to start playing Halo Infinite. I can easily minimize this, browse the web in Linux, talk on Discord, or work on a software development project. I can easily close out of the VM, run one script, and we're back to gaming on Linux. Then, on the off chance that there's one game you play that absolutely cannot run on Linux, and it has an overzealous anti-cheat software that blocks players that use a VM, you can still play that game by rebooting to a native Windows install. But I'd recommend using this as rarely as possible, because there are incredible benefits to using Linux as much as you can. The first is that there are fewer ways to be monitored by megacorporations seeking to profit off of collecting data about your behavior. The second is that you have greater software freedom to update your computer when you want and to configure your computer how you want. The third is that the more time you spend in Linux, you're helping Steam and game developers realize there is a market of people who will play their game if they release it on Linux. This video isn't about performance benchmarks or FPS, but the performance is truly impressive when playing games any of the three ways that I just mentioned. But if that's something you're interested in seeing, definitely subscribe and check out the other videos that I've already created about performance benchmarks for virtualized gaming. But right now, it's time to go into the full tutorial. Every link, command, and code snippet is documented in this blog post, which is linked in the description, so don't worry if you miss a detail while I'm running through all this at full speed. Phase 1 of our tutorial is laptop purchase and initial testing. This is the 2022 edition of the Asus TUF F15. I bought this computer because it was a good price for the specs, but also because it has 3 important features that are going to let me configure all this cool stuff. The first is that it has both integrated and dedicated graphics. The second is that it has a GPU mux switch for switching between the integrated GPU and the dedicated GPU. The third is that it has a motherboard and CPU that both support IOMMU and have good IOMMU group isolation. So now that we have the computer, we want to turn it on and make sure it works. When I turn it on, it's going to ask me a few questions. I'm going to plug it into the internet because for some reason in the modern world we need to be connected to the internet to use a device that we just bought. I'll answer a few more questions, and then I'm going to unplug the network connection because I don't want to connect to a Microsoft account. So then I'll create a local account and let the installer finish. These computers always come with some garbage programs you didn't ask for, so I'm going to uninstall this McAfee virus scanning stuff, which is probably collecting more data than the viruses it removes. Then I'll install OBS, so it's a little easier for you to see what I'm doing here. Then I can install Steam, Halo Infinite, and play a quick game. And now I'm pretty confident that this hardware is capable of the gaming performance I need, which is the ability to play modern AAA games with reasonably demanding graphics and stable performance. Which means it's time for phase 2, installing Linux and our GPU drivers. First, I'm going to shrink the Windows partition by 300 gigabytes so I have room to install Linux. Then I'm going to plug in a blank USB drive and create a Linux Live USB disk, which I'll use for installing Linux to the newly created empty space. Then I've just got to reboot, press F2 to get into the UEFI BIOS settings, and I'm going to disable fast boot, which will make it easier to boot to the Linux USB drive and the Linux install that I'm creating. I'll reboot again, press F2 again, and now I can find the boot menu and choose to boot to the USB device. I can start the installer, create Linux partitions in the empty space without deleting anything, and then run through the rest of the installer. It'll reboot a couple times, and then I'll run a command to update all the software to the latest version, and boom. Now we've got a dual booting Linux and Windows laptop, and the next step to get it gaming ready is to install our NVIDIA GPU drivers. On Fedora, that's super easy as long as you look out for two common mistakes. I'm going to run 3 commands. The first one will install the RPM Fusion non-free repositories. These are community-maintained Fedora packages with things like Steam, OBS, and Discord. Then I'll install the NVIDIA drivers with this command, and then install CUDA libraries too. I'll let that run, and now we're ready for the first common mistake. Even though the command's finished, these drivers are still building, so you need to wait like 5 minutes before rebooting the computer. When you run this command, and it returns a valid version number, you'll know that the drivers are built and you're ready to reboot your computer. The second thing that you need to look out for is Secure Boot. This driver was just built and it's going to run with the highest privilege hardware access that a program can have. So if you've got Secure Boot enabled, you're going to have to do some extra steps to sign this driver so your computer knows to trust it. For me, that's not worth the trouble, so I'm just going to reboot into the UEFI BIOS again and disable Secure Boot for now. And we're good. I can reboot into Linux, install OBS, Steam, and everything I need to start playing games with full GPU performance. Which means it's officially time for Phase 3, getting ready for gaming VMs. First, I want to go back into the BIOS and make sure I have everything enabled that sounds like it has to do with virtualization, IOMMU, and VT-D. Then I'm going to install a bunch of virtualization software. The command is sudo dnf group install with optional virtualization. And then I also want to install KDE Plasma workspaces. Lastly, I'm going to install gedit, which is a very simple text editor. I'm going to add some new Linux command line arguments and regenerate my grub configuration. I'll add some Drakit configuration for my initramfs and regenerate that too. And then I'm ready to reboot. And when I reboot, I'll make sure to start KDE Plasma with Wayland as my desktop environment, because KDE and Wayland are a great combo for easily connecting and disconnecting our GPU without needing to restart all our graphical programs, which is exactly what we're going to do next. Right now, our GPU is detached and ready to be used by a VM. You'll see here the kernel driver that's in use is VFIO PCI. If I want to use my GPU on Linux, I need to run a few commands to reattach it and make it usable to the NVIDIA drivers. The first command here attaches the GPU, so it's not going to be used by a VM. Then I'll remove the kernel modules, or drivers, that are used for GPU virtualization. Then I can add the NVIDIA drivers, and now I'm ready to play a game on Linux using the GPU. But if we want to disable the GPU again so that it's ready to use by the Windows VM that we're about to create, I'll run the opposite commands. I'll remove the NVIDIA drivers, I'll insert the VFIO drivers, and then I'll detach the GPU so that it's ready to be used by a VM. These are both operations that I like to do a lot. I want to be able to quickly enable NVIDIA, disable NVIDIA, and check which mode my graphics card is in. Because I do this switching so often, I wrote a few command aliases that will make this easier to do. I'll copy them off the blog post and save them to a file in my home folder called bashrc, which has a dot at the beginning of the file name because it's a hidden file. Now if I want to do this again, I can just type NVIDIA enable, how's my GPU, NVIDIA disable, how's my GPU. And now we're good, we're ready for Phase 4. Creating our first gaming VM. This is a pretty long process and I've documented it in a few other tutorial videos, so today I'm going to zoom through. I'm going to start by downloading a Windows 10 ISO and the Windows 10 drivers for VirtIO, which are necessary for creating high-performance virtual disks. Then I'll open Virt Manager, create a new VM from my Windows 10 ISO. I have to set the operating system to Windows 10, pick an amount of CPU and RAM, and I'll create a new 100 gigabyte virtual disk. I got to give the VM a unique name, and then I can check the box for advanced configuration. Now I got to make sure the VM is using KVM, Q35 and UEFI, and I'm going to adjust the CPU topology so the VM can do proper multiprocessing. I'm going to set the Windows 10 install disk to bootable, and then I'm going to remove the network interface card so that Windows 10 isn't connected to the internet and doesn't ask me to log in with a Microsoft account. Then I'm going to be ready to start the VM and run through the Windows 10 installer. I press any key, I'll click Install Now, no I don't have a product key, Windows 10 Home, yes I accept, and then I'll let the installer run on the new 100 gigabyte virtual drive. It's going to reboot, and I'll answer a few questions and create the local user account. I'll disable all the unnecessary stuff like usage metrics, location tracking, and virtual assistant, and this should take a few minutes and then it's done. I've got a Windows 10 VM. Now, to make sure this boots correctly, I'll go ahead and make our main disk bootable and remove the Windows 10 install disk. And now we just need to give the VM gaming level performance. First, we want to set up VirtIO for the storage so it can be fast. To do that, I'm going to add the VirtIO driver disk we downloaded earlier, and I want to create a small disk with a VirtIO bus type. Now we've just got to boot up the VM, find that disk, and install the drivers so we can see our VirtIO disk is recognized. Now we can power down and change the main drive to have a VirtIO bus type, which will be much faster. To do that, I'll need to enable XML editing in the Virt Manager settings here, and then I'll come over to the drive and change the target type to VirtIO and the address type to PCI. Then I can remove the VirtIO driver disk. I can remove and delete the small temporary VirtIO disk I created, and now we can boot the VM and it still works and our drive is upgraded to be a lot faster. The last thing that we need to get gaming level performance inside our VM is our graphics card. I'll add the network interface card back because I want an internet connection to be able to install GPU drivers, and then I'll add pass-through devices for my graphics card. Then I'm going to plug in an external monitor into my laptop's HDMI port, which is connected directly to the laptop's graphics card because this is a muxed laptop. You can see after a few minutes, Windows has figured out that this is a graphics card and installed a placeholder driver, and the external monitor is now working. But we want peak performance, so I'm going to go to the internet, download the latest NVIDIA driver for my graphics card, and install that. After a reboot, we've got a GPU-accelerated Windows VM, which can play our Windows-exclusive video games without asking us to leave Linux. But one problem remains. We can only play games using our external monitor, which brings us to the final phase, Phase 5, Looking Glass and usability upgrades. We've got 3 things to do to make this computer a lot easier to use: Looking Glass, EVDev, and Auto Login. Let's start with EVDev. EVDev is a way to switch our mouse and keyboard back and forth from controlling the VM to controlling the Linux host. To set it up, we need to first identify the paths for my mouse and keyboard devices. I'll run these 2 ls commands and look at the different devices. I can try this for all of them, but I know that this one is my mouse, so I'll show you how I can confirm it's the right one. I can cat the device and move the mouse around on the screen, and we can see a bunch of information flowing out. Then I can press Ctrl-C to get out of that, and I can do the same thing for my keyboard. I can cat the device, press lots of stuff on the keyboard, and then see lots of stuff coming out. Then I can press Ctrl-C to get out of that. Now that I know the right devices and I know their paths, I can add them to the virtual machine configuration. Under the Devices section of my XML config, I can add both devices and I can set the toggle to Control. This means that my mouse and keyboard will switch modes when I press both control keys at the same time. I also want to remove the original mouse device because I don't want the mouse to get confused if I accidentally use it in 2 ways at the same time. Now we're ready to install Looking Glass, which is a really great program. What it does is it allows you to have a movable, stretchable, and full screenable window that displays what's happening inside your VM with a high frame rate and low latency. The way it does that is by running a host program inside the VM. That program sends the display frames to a shared memory device configured in your virtual machine. That shared memory device is a file that lives on your Linux computer and has permissions set on it so that it can be used by both yourself and the QEMU virtualization software. And lastly, there's a Looking Glass client program, which runs on Linux and reads the frames from that shared file and displays them to your screen. We're going to set this up in the opposite order. First, we're going to install the Linux client program, then we're going to create the shared memory device, then we're going to make sure it has the right permissions, and then we'll add it to the VM. Lastly, we'll install the Looking Glass host application to the VM, and when we're done, we'll have all the required parts. Okay, so first we're going to install the Looking Glass client on Fedora. So Looking Glass doesn't have a Fedora package like all the other programs that we've installed so far. So what we're going to do is we're going to build it from the source code and install the required dependencies. First, let's download the latest stable release of the Looking Glass source code. I'll unzip it and change into that directory. Now I need to install all the required and optional dependency programs needed for Looking Glass. And now we're ready to build it with a few commands shown here. We make dir client/build, we change into that directory, we use cmake to generate the build files, and then we can use make to compile everything. Then when that finishes, we can run sudo make install so that in the future we can start the Looking Glass client with the command Looking Glass client. Right now it's not able to connect to anything because we don't have a VM running, but in the future this will launch a window that allows us to show anything running in our VM with high performance and low latency. The next piece we have to set up is the shared memory device that's used to share video frames from inside the VM. To do that, I'll create a systemd temp file configuration for the right file in the right location with the right permissions. I've had to tweak this from what's recommended by Looking Glass so that the owning user is myself and the owning group is QEMU. Having this file exist means that when my computer starts up, this file will be created in a way that both QEMU and my user will be able to access it. That's how the VM is going to share video frames with the Looking Glass program. The last thing we have to do to fix the permissions on this file is to set the SELinux context with the semanage command. SELinux is a set of security features for Linux to make sure the right things are being accessed in the right contexts. We just have to make sure this is set up so the VM can properly access this file even though it isn't the one that created the file. So now I'll just reboot my computer and I can check that that file was created and is created with the right SELinux context using the command ls-alz. And it looks like it works. Now I've got to add that shared memory device to the VM configuration. We've already enabled XML editing, so then let's open the XML config for the VM and I'll add this snippet from the Looking Glass instructions for the new device. Now I can start the VM, and inside the VM I need to tell it to cast its screen from the HDMI out here to the shared memory device. So I'll just download, install, and run the Looking Glass Windows host program. Once it's installed, it should start automatically in the future when the VM starts up. So now I can run the Looking Glass client on the Linux host, and you can see it connects and it's showing the same thing that's going out the HDMI port. We can't get rid of the HDMI port because the Windows VM needs to think something is plugged into the GPU for it to use the GPU's performance. But we don't need an external display plugged in all day long. So I'm going to replace this HDMI cable with this dummy plug, which doesn't actually display anything, but emulates an HDMI output like I showed in this other video. And now I've got a way to get high performance game running inside my VM and a really easy way to display it to the screen on my laptop. I'll also make sure that the audio is working too. Inside the VM, I just have to make sure the output device is set to default speakers and not the GPU. And then on the host operating system, I need to make sure that I have this Spice window open so that the audio can come out of it. And you can see the audio is working here as I make a little noise in the VM and it's successfully coming out of the laptop. And that's actually why I'm using the -s flag here, because it allows the Spice display to keep working even when Looking Glass is running. I also want to be able to use shortcuts with Looking Glass, and most of them are hotkeyed on the scroll lock button. This is tough because my laptop doesn't have a scroll lock button. So I'm going to rebind that to the right control key using the argument -m97. The same thing as earlier with our commonly used commands, I'm going to save this to bashrc so that it's easy to launch later. Next time, I can just type in the command Looking Glass and it will launch with my predefined settings. The last convenience we'll add is Windows Auto Login. Like I talked about earlier, the whole point here is about smoothing the process of switching between Linux and Windows so that we can spend more time in Linux. So I'm going to configure Windows to automatically log in with my username and password by editing some things in the Windows registry. In the VM, let's open Registry Editor, navigate to this folder, and add these 3 entries. And next time we start up our VM, it will auto log in to Windows, as we can see here. And that's it, we're done. This computer has been configured to do everything that you saw in that demo. Gaming on Linux, gaming on a Windows virtual machine, gaming on a native Windows install. But most importantly, easy switching back and forth between the two to allow you to spend more time using the operating system that you want to use. To conclude this video, I want to be really clear about my intentions. I'm making this tutorial as a sweepstakes style giveaway because I think it'd be really cool if I could say that I made a video that got 1 million views. But more importantly, I want to put my money where my mouth is. I truly believe that mainstream adoption of this technology is going to be good for the Linux community, but also good for innovation in the gaming industry as a whole. And I've noticed that doing giveaways is a great way to garner mainstream attention for YouTube videos. So I've done my part. I spent months ironing out the configuration and making this tutorial as straightforward as I possibly can. So now it's in your hands to like, comment, share, and do whatever it is that you can do to get this video in the hands of everybody who'd want to see it. I'm really excited because if this video gets enough reach, somebody's going to get some really great news. If that person's not you, and if configuring a computer to do this yourself is outside your current skill set or not an effective use of your time, I also have an online store where I'm selling custom pre-configured PCs like this one that come with special access to Discord support channels, and there's a link to that store in the description. Thanks for making it to the end of the video here. If you finished this tutorial, that is a truly impressive feat. So as always, thanks for watching, and don't forget to stay bland.